Welcome to AI Frontiers. Today's episode explores the robotics revolution through 10 cutting-edge papers published on August 21, 2025. We'll examine breakthroughs from simulation to real-world deployment, where artificial intelligence meets physical intelligence. This journey through robotics innovation will cover an overview of the field of computer science robotics, dominant research themes emerging from these 10 papers, key technical breakthroughs and methodologies, 3 seminal papers representing the field's direction, and future research trajectories and challenges. Computer science robotics represents the intersection of digital intelligence and physical action. This field creates machines that sense, think, and act in physical environments by combining mechanics, electronics, and advanced AI. These systems transform dangerous, precise, and repetitive human tasks, moving from controlled labs to unpredictable real-world applications. The first major theme is learning through experience, where robots learn by doing rather than executing pre-programmed scripts. Chen and colleagues explored policy idling for dexterous manipulation, while Azadjou's team taught quadrupeds to walk from scratch. These systems learn from data, practice, and even mistakes, moving beyond pre-programmed scripts to adaptive behavior. Theme 2 focuses on the simulation to reality bridge, where digital twins accelerate real-world deployment. Xu and team developed the Neural Robot Dynamics Simulator, compressing years of trial and error into hours. This virtual training transfers seamlessly to physical robots, reducing hardware costs and increasing safety during development. The third theme involves language and vision integration, creating robots that understand and see like humans. Nguyen's group worked on language-guided pallet loading systems, while Kachaev's team built a benchmark for verbal command following. This represents a shift from code commands to natural language interaction and visual understanding of cluttered, complex environments. Key findings demonstrate breakthrough performance with quantifiable advances across multiple domains. These include 96.25% real-world success rates for autonomous drones, 35% improvement on delicate insertion tasks, generalization across tasks and environments achieved, and real-time adaptation and self-correction demonstrated. Methodological convergence shows shared technical approaches across research. These include learned models and neural networks for complexity capture, trajectory optimization for precise motion planning, large language models for common sense reasoning, and hybrid approaches blending physics with learning. The paper of the day is Neural Robot Dynamics by Xu and colleagues, revolutionizing simulation accuracy. Their general-purpose simulator achieves both speed and accuracy, with a learned model handling contact and dynamics within existing frameworks. The robot-centric view enables portability across tasks, and policies transfer successfully to real robots. SRDrone by Deyu, Zhang and team represents self-refining autonomous systems with continuous learning in action. The system monitors performance continuously rather than just final outcomes, uses large language models to analyze feedback and adjust behavior trees, achieves over 96% success rate after self-correction, and demonstrates embodied intelligence through learning from physical experience. Annie Chen and colleagues' work on policy idling turns stuck moments into success with simple solutions for complex problems. Their method detects when robots make tiny, useless movements and provides pause-induced perturbations, small random pushes that require no retraining or additional data. This approach delivers dramatic performance improvements on delicate tasks. Future directions point toward the next frontier in robotics research. Key challenges include closing the sim-to-real gap completely, enabling lifelong learning throughout operational life, enhancing human-robot collaboration and understanding, and achieving reliable operation in truly unstructured human environments. This presentation was created through AI synthesis and review processes. Content was synthesized using the GPT deepseek-chat model, with text-to-speech synthesis via Google Technologies and image generation using StableDiffusion. Human expert review was conducted for accuracy, though potential oversights are acknowledged despite this review. Subscribe to AI Frontiers to stay updated on cutting-edge research. The channel provides regular deep dives into emerging AI research, daily paper reviews and technical breakdowns, expert analysis of trends and breakthroughs, and is available on YouTube for more content. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses archived preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archived preprint server.